the groups of sectors together.
Good question. Good question.
In what situation is classic disk storage better than a solid state storage device?
Classic storage versus solid state. Classic storage, like hard disk drives, it's cheaper and you can store more. Basically, that's it. But solid state drives are just way faster, so if you can afford to use some.
Yeah, I think it's if you're moving large data constantly, I believe solid state drives can wear out faster than a hard disk can. So for PCs though, if you're just doing lots of small movements, solid state drive would be better. So like you play lots of games that use constant small calculations and just move small bits of data around, solid state drive would be good. But for large applications, huge pieces of data, we want hard disk.
Which group was that?
7.
And the first question?
Hey, what group are you guys? Hey, Dylan, what group are you? 9.
Thank you.
Can you elaborate on the raids like stuff again? I didn't catch a lot of that. What is that? What are they? What do they do?
Here, let me see your image card. Can you ask a question again?
Yeah, I just wanted to kind of understand what RAID is.
RAID.
Just brief understanding of it.
RAID. Levels are from 0 to 6. Each level has a different balance based on some goals such as capacity, reliability, availability, and performance.
Is it like a protocol?
That's about it, man. Right?
Okay.
Sorry.
I guess there wasn't that much like in the textbook.
I didn't know if it was like a big section of it or whatever.
It's a redundant, inexpensive array of disks, so it's used for redundant storage of data, so to create backups and stuff.
Thank you.
Which group was it?
2.
How come all the parameters didn't increase like at the same speed? So like your rate time and your capacity, they're different. Like the way they increase. For your disk, sorry.
Can you say that again?
So for your disk, you have the different parameters, and for the seek time, it's not as good as like the transfer rate. Like the way that things increase, they didn't increase in the same like speed, if you will.
Seek time is variable, like based on where the arm is. So like if you have to go from cylinder 1 to cylinder 38, it's going to take longer than going from cylinder 1 to 2. Because the arm only has to move this much. But read times are always the same once the arm gets where it's going.
Which group were you?
So out of those 3 seeking algorithms you discussed, which one gives the best performance?
Elevator, the last one.
Question?
Like for the algorithm, or is like writing, it like writes to the backup always. You said so it writes to the first one, and then like later it writes like that one writes to the copy, or like so. It was like with the pictures you had it writes to the first memory, and then like at what point does that memory write to the second one to where it has its duplicate? When does
Say that again?
so it writes to like the first memory, and there's the backup one. Like when does it write? When does it copy to the backup? Like and when does that go?
So after it writes to the first one and everything's complete, it would copy it. Like at the end of the day, it goes through and checks like every corresponding block, and so at the end of the day, it'll make sure they're both the same. So basically every 24 hours, unless there's like a recovery or something.
So you said like it writes to the first one, and then if there's an error in the first one, it will just take whatever is in the second one and replace what the error was.
Right, like if you're going back to read something from one of the two,
Yeah.
you always start with the first one. If the first one's corrupt, after an amount of tries, or whatever the explicit attempt number is, then you try it from the second disk.
So what happens if like an error occurs on the first one, or no, if you write correctly on the first one and an error occurs while it's trying to copy the first to the second one, and then it writes again to the first one and an error occurs there, and so the second one's, and so the second one was never corrected, and then you have like an error on both. I don't know.
So I guess you just kind of hope that like that doesn't happen enough.
Can that happen? That's what I'm wondering. Like,
Yeah, I think it can, but I think it's like almost the point where it's there's such a small chance of that happening. You just take your chances.
it's like, it would have to occur, so to speak.
Right, it happened to happen. Yeah, so it can't happen, but they say you got a really good chance of that not happening.
So
Both not
there's no
being
confirmation saying like the data was written correctly to the second one. Like, so if it writes well to the first, like, so you're good, you write to the first one, and it starts to write to the second one. If there's an error there, would it mark that as unusable memory, or would it not?
I'm not sure exactly, but the way I saw it, the way I read it was that basically it writes to the first one, and it usually has success, and then at the end of the day, it'll copy to the second one. And so, if there is a problem, I mean, obviously you'll get an error, and then
So there's not.
if they were both messed up, you just have to replace the disk.
So whatever the protocol is for like copy error, you didn't really see or anything about
Right,
it.
right.
Okay. Which group were you? Which group was that?
Regarding this on scheduling algorithms, seek time is said to be the predominant factor in terms of efficiency. I want to know, are rotational delay and data transfer time entirely negligible, or do they make some substantial impact of their own in algorithms?
Seek time, if you're talking about like basic, like in the book, basic hard drive, seek time is so much longer than the other two. Then we try to minimize those with the algorithms. But in like modern hard drives, the rotational delay, it also takes into a factor. So instead of like trying to read a specific block, since that will take time to find it, they just read a whole bunch of sectors at once and store it in memory.
Good question. Which group was that? Six. And group 4?
And do you know if magnetic storage is used in anything besides hard drives, or is it just for hard drives?
Don't like tapes use magnetic storage?
Yep.
Yeah, cassette tapes. But like I said, those are the original hard drives, weren't they? I'm not sure what else uses.
Like nowadays, and it's primarily just for hard drives.
VHS.
And the last question, group 5? Group 5 is the presenters. Okay. Well, let's applaud the presenters. Thank you.